house mice, cockroaches, bed bugs, these things live amongst us. They're commensal. They rely on our societies, and they affect us more than any other creatures.
I wanted to ask you, was this a passion project, getting involved in rodenticides and resistance?
What exactly is going on with the secondary poisoning and non-target exposure? Why exactly is this occurring?
Hello, and welcome to episode 5 of the Beyond the Pest podcast. I'm your host, Jen Sweeney Ingram.
And I'm Michael Thome.
Today, we are branching out from our typical guest. We have interviewed Luigi Richardson in Ontario. He did some research on rodenticide resistance, which is a hot topic in the pest control industry today. Very smart guy. Great conversation. We think you'll enjoy this one. So please welcome Luigi Richardson. Hey, Luigi. Thanks for joining us.
Yeah, great to be here. Thanks for having me.
Yeah, awesome that you're hopping on today. And Mike, you've got a new mustache going on.
Yeah, mixing it. Look, I can't change my hairstyle, so
There's just a lot of mustache going on in this one today.
Exactly, right? Can we like superimpose one, or can we draw a finger here real quick
Totally.
there? Right?
Give me something I can't do. Yeah.
Right? Exactly. So, but no, when you can't change the hairstyle, you got to mix the facial hair up every once in a while.
For
so.
sure. So none of us are in Florida today. So
No,
Can't wait to go down there fishing sometime.
Luigi, I'm so glad you said that because this is a great segue. So
Yes.
you allowed me the privilege of reading your thesis. And I have to say, it was very long, so I wasn't able to fully digest it. But
Right.
what on earth is an electrofishing technician?
Okay, so
Okay, let's go.
Yeah, this goes back to my background with natural history and how I got into biology. Electrofishing is just a technique whereby we're using an anode, a positive charge, to shoot a very light electrical amperage into the water just to basically stun the fish temporarily. Imagine you've maybe seen it on television. And then we can collect them. And you can put them in multiple containers, sort them by species. You can measure them. And that can allow you, if we're doing river electrofishing, to get an idea of the species assemblage, how healthy the community is, that sort of thing.
Oh my gosh. So, okay, well, yeah. So before we get into your background, so you recently graduated, or at least you defended your PhD recently. Congratulations.
Master's, actually. Yeah, this is my master's.
I thought it was your
PhD.
PhD.
PhD is going to be September 2026. I'm going to be starting.
Oh
Where are
my
you
God.
starting at, if you don't mind us asking?
Same university. So Laurentian University. That's up
Okay.
in Sudbury, Ontario, and most people south of the border aren't going to know where that is. So just about four hours north of Toronto. And yeah, it's even colder up there than it is down here. So
Oh
We
my
were
gosh.
trying to do some Fahrenheit to Celsius calculations before you jumped on, Jen. Needless to say, neither one of us are math whizzes. I'll just put it that way.
It's easier to go from Celsius to Fahrenheit.
I think so.
Just
Yeah, probably.
times 2 plus 30, but I can never, my brain, yeah. The reverse is, yeah, forget about it. You don't need it. Awesome. So, yeah, so listening to you defend your master's thesis then was awesome. That was really cool. So you basically put out a message on LinkedIn because we're friends on LinkedIn. That's how I met you, so to speak. And you said, hey, anybody that wants to sit and watch this thing, feel free. I'll send you the link. And so I did. And so one of the things that I thought was funny was in the very beginning, I don't know if it was one of your advisors or somebody else, but they said, are you nervous? And you were so confident. You said, no, I'm excited. Let's do this. And I was like, I wanted to ask you, was this a passion project, getting involved in rodenticides and resistance, or how did you even go to school for this? So you went to school for entomology, I presume, and then how did you get involved with this project in rodenticide resistance?
Yeah, so I'll keep it short. My entomology knowledge has been largely self-accumulated. I've been in the industry and learned a lot about bugs, and that in itself was what inspired me to learn more about them. I've taken a whole bunch of asynchronous online courses, and I've been studying for BCE for the past 4 years. Even though I don't have any degrees in entomology, I do meet the standards. So I'm hoping to take that exam in the near future. But when it came to this project in particular, so I started off in community college, looking at natural history and field biology, transferred to university. But before I did that, I basically wanted to work. I wanted to get some field experience for a little while. So after I finished community college, which was 3 of the greatest years of my life, had a lot of fun studying fish and wildlife technology in another small town near Peterborough, Ontario. I just needed a job, and I'd done some trapping with my dad years prior. He was the one who got me interested in, well, biology, because I grew up as an angler, fisherman, and I love birds or birding, bird watching. And so I needed a job. I wanted to work with wildlife, and I had done a co-op with a pest management company. So I said, okay, you know what? Let me give this a try. And I tried it starting in 2020 and became engrossed in it. And I said, you know, I've always wanted to do research. Why isn't that? Why is it that none of my professors have have taught me about the urban ecosystem as it pertains to pests? I mean, I'm in a fully detached house right now, and this is an ecosystem because there's living things here, and they have a very distinct ecology that's so understudied because there's no glamour to it. People would prefer to, look at polar bears up in the Arctic or some other exotic, illustrious species, but house mice, cockroaches, bed bugs, these things live amongst us. They're commensal. They rely on our societies, and they affect us more than any other creatures. And Bobby Corrigan says it all the time that we have more contact with the house mouse than anything else. And so I really wanted to study these things. And rodenticides, pesticides in general, were, because of my background in environmental science and conservation, something that, I don't really like the idea of pesticides. But after seeing this type of stuff that I saw, being a technician, I make no apologies whatsoever for my use of chemicals. Do we have to be careful with them? Absolutely. But we use them and we have them for a reason. So I said, these rodenticides are so controversial, but what exactly is going on with the secondary poisoning and non-target exposure? Why exactly is this occurring? And how can we figure out how to use these things more effectively? Because I used all kinds of rodenticides, and the sort of hearsay in the industry up here in Canada is that, oh yeah, we stopped using warfarin 20, 30, 40 years ago because they're resistant to the stuff now. Oh, okay, resistance. It's a genetic phenomenon. Has anybody studied it in Canada? Nobody's looked at it. So if we could find resistance and determine the pathways of non-target exposure, we could develop a new protocol for the industry, or at the very least, just figure out what's going on so that we can use these chemicals properly, or at least, to a much more efficacious degree in perpetuity, protect the industry and protect the environment. And I think that we can do that. That was the inspiration.
Yeah. So in your thesis, the part that I was at the very beginning, when you're thanking everyone, you said you wanted to thank your advisor. He said something like he put his arms up and said, well, you got what you were looking for out of this project. What were you looking for when you set off to look into resistance in Canada?
Ultimately, the truth. And what does that mean? Well, first of all, the second generation anticoagulants, which are designed to control rodents that are resistant to first gens like warfarin. These second gens are potentially very dangerous for wildlife because they're very toxic, they're very persistent. We hear a lot about pesticide persistence when it comes to the history of organochlorines. Nowadays, with neonicotinoids, they're systemic. I wanted to figure out, are these things really necessary on their face? Like, do we need them here? We know that this resistance has been observed. It's being documented in the United States. It's being documented all over Europe, all over the world. Do we have it here? And if we do, then okay, we can say that if we're going to use chemicals, anticoagulants, the second gens will be necessary. That's part one. And the second half is, why exactly are they spilling over? Or, can we find a way to avoid the type of, how would you say, spillover, the type of excessive use or improper type of use that could unnecessarily threaten wildlife, like just to be more frugal with these super toxic chemicals and use them only where they're truly necessary so that we actually have the desired effect and control those resistant rodents, but also prevent them from killing wildlife. So it was a desire to determine if they were necessary, and if so, how to use them safely. That was basically it.
So I wonder, before we kind of get into the nitty gritty, can you tell us a little bit about what can Canadian techs use now? One of the questions I had, like in the US, we're always talking about how civilians, lay people can just buy anything for their private property. So you can go on Amazon, you can buy some whatever, pick your poison, literally. Is it the same in Canada? And who can buy?
So basically, you either have to be a certified farmer or a licensed exterminator working for a company that has an operator's license in order to buy second generation anticoagulants. They're all commercial grade, they're all restricted. You can't go to a hardware store and buy those. The first gens, warfarin, chlorphacinone, and diphacinone, those are the ones that we have. Those you can buy domestically. But yeah, the second gens, you need to have a license or you need to be a farmer in order to purchase those.
So were these regulations put in place by more environmental groups? And do you have any thought or any information about, like, if there was pushback from, the chemical manufacturers, from technician groups?
Yeah. Well, there certainly would have been pushback, as there is today, because in Canada and in the United States, there's a lot of petitioning against rodenticides, period, whether they're first or second generation.
Right.
But back then, I would have to imagine it was what would have been the Pest Management Regulatory Agency, which is like our branch of the EPA that controls pesticides in the country.
Huh. So walk us through your project. What did you do and what did you find?
Yeah. So basically, the only real way to get your hands on commensal rodents, for the most part, because of the way they live inside of houses and buildings, private property, is we needed to get pest management professionals to donate them to us. And we just needed their DNA, house mice and Norway rats, in order to test them and look at what's called the vitamin K epoxide gene, which codes for rodenticide resistance. So over the course of about a year or so, we got a bunch of different companies, some large, some small, in Ontario, mostly in the Toronto area, but in southwestern Ontario and in eastern Ontario and to some degree in northern Ontario, to donate their samples to us. And we ended up testing them along the way. First, you basically take a small piece of DNA and you put it through a whole process whereby you can extract the DNA and then amplify the gene you want to look at. Most of that's over my head. And I know it sounds like I know what I'm talking about there, but we had collaborators that were able to help us along with that. So that was one half. And from there, we wanted to figure out if this resistance is associated with any factors that could allow industry to actually predict it. So, are there more or less resistant rodents in, say, suburban areas or rural areas or areas where there's more higher income or lower income? And you'd say, well, why would that even be the case? Well, depending on the neighborhood that you're in or the landscape, people or businesses may be more or less likely to hire pest management or to use their own chemicals. And so if you have a very sustained usage of, say, a chemical like bromadiolone, you have a long-term usage of that chemical in a house mouse population, eventually, in a lot of cases, you'll kill off everything that is susceptible, and the few in the population that were just naturally resistant, they'll remain. You'll think that you've solved the problem, and then it might be 2, 5, 10 years later, they come back, and you put down the contract, and now it doesn't work anymore, and that's how resistance proliferates. The other half was the pathways of secondary poisoning. So a poisoned rodent needs to be available to a predator in order to cause secondary poisoning. If you're poisoning rodents 20 floors up in an apartment building where you're probably going to be dealing with house mice. Doesn't matter how much poison you use, chances are those house mice are never going to run 20 floors down out the front door to an area where a hawk or an owl or a fox might end up eating them. So they need to be available. And so we found grocery stores and other factories, warehouses in the Toronto area where they had ongoing outdoor rodenticide use near naturalized areas where we're going to have urban predators. And we said, okay, if we can trap rodents in this area, we can get an idea of the degree to which these rodents are moving into the urban area onto the property to eat that rodenticide and then go back to the natural areas where all the predators are going to be, because that's where the risk really is. And if we can determine what those poison rodents might have in common, we can say, oh, well, you know what? All the industry needs to do is perhaps, well, use a different chemical, don't expose this species, don't use so much chemical depending on the area, so on and so forth. And we could, prescribe a new use protocol. So we just wanted to figure out exactly what was happening with resistance, if we had resistance, to justify the second gen rodenticides and figure out how chemicals could be causing secondary poisoning, the industry's use of chemicals, so that they could modify their usage practices.
Yeah, being a trainer, in pest control, I find that there's so much, I think, blame sometimes when a lot of us work in more urban areas. And so, we are dealing with kind of, houses that are close together. And then we might wonder, what are the so-called predators that are eating that might be exposed to a rodenticide in a tamper, resistant bait station on the exterior of a house, for example. So, yeah, I wonder if you could talk a little bit about the predators, because I think we get a lot of, certainly from, PETA groups like this, for animal groups, advocates, the average layperson who is against the pesticide industry, our industry. Um, yeah, I think there might be, and on our side, in the pest control side, I think there might be, well, that's, if there's any predators that are eating prey that have been exposed to rodenticides, maybe that's the agriculturalists, the farmers, or maybe it's, just rural, more rural people who are buying stuff on Amazon and throwing it out there. By the way, one of the most fun, not really fun, but interesting things that you could do is go on Amazon and read those rodenticide reviews and just see the misapplications that are right there blazingly in the comments. So
Right.
that's a good pastime. But yeah, I wonder if you could talk more about that, because that is really one of the pain points, I think, in our industry. It's like, well, we want to keep using the rodenticides because they're a cheaper option for people. And you talk about, the urban and rural areas, and I know that was part of your thesis. But
Mhm.
what do we do? Like, what are other options? What can we do?
You know, to ask about other options when it comes to rodenticides, it's obviously an excellent question, and we ask that all the time. But when it comes to the idea of other options than rodenticides, I think exist for other reasons, in the sense that, and I'll explain, in the sense that if you have, you have people with lower income that can't afford to perform exclusion around their entire property, or you have people who are just unfortunately living next to others who are less than hygienic about their backyards, and they perhaps don't clean up their dog poop, or they have too many bird feeders. They don't trim their grass. I used to see that all the time as a tech. There aren't too many other options that are as efficient as rodenticides. Now, doesn't mean that they're a blanket solution. Of course, we all know this. We hear all sorts of talk about exclusion, exclusion, exclusion. When I worked for a couple of smaller companies in this Toronto area, exclusion was like my bread and butter for rodents. And if you've ever done it for mice, I mean, it can be an absolute nightmare. But that's how a lot of the smaller companies compete with the big guys who are using all kinds of rodenticide. And up here, a lot of the bigger companies, they get all the big commercial contracts, these big national accounts. And so exclusion can be really, really good in the suburbs on, especially on fully detached houses in middle class or upper middle class neighborhoods, because usually the properties are well maintained. You can see everything around the foundation. Everything's wide open, and people are more than willing to cooperate, and they're more than willing to spend the money that they need to get the job done. In a lot of cases, I would tell people, I'd put down my traps or rodenticide, and I'd say, come take a walk with me around the house, and I'll show you everything that's wrong, and I'll show you exactly how to fix it yourself. A lot of times they'd just say, just go ahead and do it. When can you come back? Because they trust you. Getting rapport with customers and gaining trust by showing them what you're going to do and dropping a little bit of scientific knowledge is always a great thing to do. But the rodenticides, we're going to need something that is just as low cost, just as easy to dispense, and just as relatively discreet as the anticoagulants to replace them. I'm really convinced of that. I know you guys have some products which some people, not going to, defame the companies that are making these. I'm sure they work, but I've heard the birth control products that you guys have, we don't have them yet. Some people have said, well, they're not working so well. Won't ask for your opinion on that, but I would love to try those. I don't know that I think there's been a few published papers related to the birth control products, but there are other rodenticides like cholecalciferol. You guys have a product called Cadet. We don't have it. There's alpha chlorelose, which really only works in lower temperatures, as well as a few others that are not posing the same risk of secondary poisoning. But up here, there's this idea that exclusion and trapping and cultural modifications of the property are going to substitute for rodenticides. If those methods are going to substitute for the rodenticides in a particular case, I don't think you're using the rodenticides properly. In that, if you can do exclusion and if you can modify the property, removing or perhaps better proofing your composting bins, whatever it may be, and that eliminates the need for a rodenticide, you probably shouldn't have been using one to begin with when you really think about it. But we all have stubborn customers that, oh yeah, I'll get around to fixing that. And, they never do. And we show up to an account and they say, oh yeah, that stuff from the hardware store is garbage. You got the good stuff though, right? Yeah, make sure you put down the good stuff. Alternatives to rodenticides, traps are not the answer. Traps have a very definite place, but we're going to need something similar for the foreseeable future. Perhaps birth control, rodent birth control products. Perhaps those will be, at the very least, the beginning.
Luigi, when you were looking at the levels of resistance that you found, like what kind of numbers are we talking about here? Are we talking, do you know what I mean? In what you tested, is it 20% of the rodents that were resistant to first gen? Is it 30, 50? Where were we at?
It's 98% of the house mice that we tested were resistant to first generation anticoagulants and to bromadiolone. Now I'll explain what that means. When we talk about a resistant, and none of the Norway rats that we tested were actually resistant. We had about 56 Norway rats from all over Ontario, 55 house mice. Admittedly, it's a small sample, but we still had a very high prevalence. Resistance in and of itself doesn't necessarily mean, it's not quite the same as insecticide resistance, obviously quite similar, doesn't mean that a rodent can consume an unlimited quantity of the poison and never succumb to it. Resistance basically means that there will be a practical effect in the field whereby you're going to put down the prescribed amount of bait, and it's not going to do the job. So when it comes to the mutations that we found to measure resistance, the ones that we found were so prevalent and usually in what we call homozygous form, meaning that the mouse got one copy from the mother and one copy from the father, that they basically confer factors of resistance that are in the 100, 200, 300, 500 range to the first generation anticoagulants, which means that rodent would have to eat 100 times, 200 times, or more, hundreds of times the amount of poison in order to actually succumb. So that's an insane amount of poison that you're never going to be able to dispense that much.
Yeah.
And chances are, even if you were able to kill them, by the time you do, they're going to have reproduced 2, 3, 4 generations, and their grandchildren are going to be coming after you, and you're not going to get them under control. But even to bromadiolone, I mean, they were resistant in the factors of about between 5 and 20. Usually it was about 17 to 20. Those were the resistance factors that we were seeing. So, I mean, a contract block bait station that typically holds about, let's say, 8 blocks of contract. Let's say you got an Evo Express. There's about about 17 to 18 lethal doses in one block of contract for a fully susceptible house mouse. Those ones that were double resistant, there'd only be about the lethal dose that you'd need for maybe 2 or 3 in that one block. So, I mean, you've got a drastic increase in the amount of bait that you're going to need, and you're never going to be able to eliminate them quick enough, which is why you'd need something stronger like First Strike, diphthiolone, or brodifacoum. Up here, we've got Final. You guys have one I think it's a thin sort of bluish block. I don't know if it's Talon or what it's called. You've got a few other chemicals down there. But yeah, a lot of resistance. And it was
So
all over Ontario.
none of your Norway rats showed resistance to even first gens?
Well, no, but this is where it can get complicated. So we didn't find any genetic resistance to any anticoagulants in the Norway rats. Keep in mind, we get cross resistance with first and second gens, of course, because they all have the same mode of action. They're almost like hormone blockers. They imitate vitamin K, which is why vitamin K is the antidote, and they bind to the receptor so that vitamin K can't enter. The blood stays too thin. The animal bumps into something, it hemorrhages, and it ends up dying. We didn't find any mutations in the Norway rats. The thing is this: you guys had a phenomenon back in the 70s or 80s, particularly in Chicago. They called it Chicago Norway rat resistance. There's a professor at Bowling Green University. His name was Bill Jackson, who was studying this decades ago. And they have documented a mutation in Norway rats from Chicago that causes resistance. But there's also another factor. Norway rats, and I think house mice on occasion, will have a particular bacteria in the gut that will create or synthesize vitamin K. It'll create an antidote for the rat. So you can test them genetically, and they don't have any resistance mutations, but they're actually still resistant by, to extreme degrees in many cases. And we can only test that by looking at the gut microbiome. So we may have resistance up here in a different capacity, but that's where it gets so much more complicated, and it's much more difficult to track. If you're interested in that, the one person you should contact, and maybe you should have him on, he runs a company called Genesis Laboratories in Colorado. His name's Richard Poche. I can send you his information. He's done a lot of work on gut flora anticoagulant resistance in rats. Really interesting work.
Oh my gosh. There's so many types of resistance. That's what's so frustrating also. Because another thing we like to say is, well, they're not taking our bait, so maybe they're bait averse,
Mm-hmm.
Frustrating.
That's a whole other thing. Yep. And it's something that we deal with in particular with Norway rats. I haven't really had an issue with bait receptivity when it comes to controlling house mice. But certainly with Norway rats, they're very, very finicky. Sometimes it takes them like 2, 3 weeks just to enter an exterior bait station. That's what I've found. I don't know what do you guys deal with roof rats down in Tennessee or Ohio type here?
So not so much in the region that we live in, but in the regions that we support, yes. So further down south, and then out on the West Coast, California area. So
Mhm.
Nashville's gotten an influx of them over the years. I guess it started more like 2010, 2015. But since I've been in the Nashville area for about 4 years, I've gotten a lot more calls for them. So
Mhm.
yeah,
Mhm.
still majority Norway rats though.
Mm. It's kind of like the Turkestan cockroach thing that they're having in New Mexico and California. I think they're dominating over the Orientals. I think it is.
And spreading too.
Same
So
Yeah.
we're
thing here.
finding the Turkestan more and more. Have you guys gotten them in Tennessee yet, Jen, or no?
I pretty much only find them now. We don't find Oriental cockroaches.
Interesting. Interesting.
Hmm.
We
Yeah,
get a
it's
lot. We get a lot of Orientals in downtown Toronto. You get them in these old buildings that are like 100, 200 years old, and they're all connected, and you you control them in one area, and they move, and they're such a pain to deal with.
they're not good flyers, right? So they just kind of stick within a vicinity and
Yep.
but
Yeah.
why are they tough?
Oriental roaches, I don't know.
Yeah, so
No,
do
it's
they
I'm gonna go with Luigi. It's one of my least favorite things
really?
to deal with. I think it's part
Wow.
of it is that they, I think back to my years as a technician and the amount of times that I would find them living under some concrete slab. It's not something like American cockroaches. I think it's pretty easy usually to kind of dial in on where I need to go to look to do the inspection piece of it. Um, I was just in a warehouse the other day in Western Pennsylvania, and for absolutely no reason whatsoever, coming up out of a crack in the floor are cockroaches. There's no reason for them to be there, but yet there they are. So I think that's what makes them so hard is that there's not always that like, oh hey, this is my pest. I know where I need to go. I think we get pretty good at that, dealing with the species we encounter. But for whatever reason, the Oriental cockroach, it just doesn't seem to follow any rhyme or reason when it comes to looking for harborage areas.
They're like, "We can't fly, we're slow, so we're just gonna be in the most
Exactly.
painful area we could
Yes,
possibly
exactly,
be
exactly.
to
Let's make this
ruin your
really fun.
day." Oh my
Yeah.
So,
god.
Luigi, where does the research go from here? Is there plans to take it further or?
Oh yeah. Oh yeah. And we'd really like to hopefully put together some collaborators south of the border that might be able to help us maybe put together this resistance puzzle. In that we know that you guys have resistance down in the Northeast and the American Midwest and all over the states, but in particular, you have similar patterns with these mutations in the states that border Ontario. And so I have this theory, uh, unfounded, and my committee has pressed me to, not be too speculative, but I think that there might be two paths. And I'm going to be really happy in a few years when we do this, and maybe I'm vindicated. I think there might be two paths by which house mice might be flowing back and forth between Ontario and the United States. And that's basically the border at Niagara Falls near New York State, coming up into the Toronto area and south central Ontario, and the border at Detroit coming up through Windsor, because we have these two characteristic mutations that line up so well geographically. And there haven't been really too many other papers that look at the geographics of resistance mutations in this manner. And if we could look at them cross borders, that would be really neat. But the other thing that we want to look at, I talked about the gut microbiome thing with Norway rats. I'd really like to do something with that. That's in the very early phases. Don't know what we'll do, but I'm going to look into that. The other half is we want to look at maybe seasonal variations in the spillover of rodenticides into wildland areas, because the trapping that I did of white-footed mice, which are a deer mouse, in Toronto, I only did that in the summer. If you imagine, what things are like in the wintertime when the forest floor is all covered in snow, and maybe even the parking lot that separates the forest from the commercial building is covered in snow, maybe those mice are going to be much more bold, and they're going to go across that snow, take that rodenticide, and then bring it back in the wintertime. And then maybe we could say, well, be a little bit more careful with your rodenticide usage in the wintertime, maybe move to more so indoor usage, or use it in areas where there's going to be less risk. So seasonal patterns, other mechanisms of resistance, but also the genetics of these mice in a population genetic sense. Like we would really like to figure out if there's different strains or different directions of gene flow. Like, are the mice in northern Ontario more related to the ones in southwestern Ontario than the ones in central? And if they are, maybe that lines up with some sort of shipping route. Um, And, the industry could potentially use that to say, well, the protocol on one side of the border is causing this and it's spilling over here, and that means we need to use a different chemical, or we need to cycle chemicals, or maybe we can now petition in Canada to get some of the chemicals that you guys have, because we don't have cholecalciferol, we don't have any of the birth control products up here. If we can show that some anticoagulants are ineffective, then perhaps we can justify the registration of newer products that have been very well proven south of the border. So we really want to definitely go farther with what I've done, what we've done. I'll say the royal we, because I have a whole bunch of committee members that have advised me on this. I couldn't have done it without them.
Yeah, it certainly would be nice for every single city in the US too to have a Luigi in your lab crew to let us know how resistant our populations are, because I mean the majority of us are just rotating, baits as needed, or just saying to hell with it. We're just going to have to up the price for exclusion or what have you. But it's interesting, 98% in the house mice in Ontario. I mean, I am just curious to know how widespread that is in the States. Like, that's
Mhm.
crazy. 98 is crazy.
Yeah, and because it lines up so well with the different landscapes that we collected these from, in that we have resistance everywhere, whether it's rural or urban. But in those urban areas, we have a ton of this homozygous resistance, which is double resistance. That sort of tells us, and it confirms the rodenticide usage patterns in those areas, in that the companies in Canada, we only have one chemical that we can use outdoors, and it's bromadiolone. We can use the first gens outdoors, but nobody uses them. Very rarely, at least. There's one product, there's Flatline. That's the only commercial grade first gen anticoagulant that we have up here, and it's very seldom used. But that in and of itself really proves that if we're going to be using rodenticides, we need to be able to use our diphthialone, First Strike, our brodifacoum, Final Block, and some others in an outdoor capacity as well. And what they've done here in Canada, and again, this goes back to, I guess, 2012, is they've restricted those super strong second gens to indoor usage only. And so the idea is that, well, if you're only using them indoors, these mice are going to stay indoors and they're not going to go outside. They're not going to poison predators. There is that persistent myth in the industry that I'm sure you guys have heard, that I heard from a few techs when I was coming up, which is that, oh yeah, the rodenticide makes them thirsty and they're going to go outside and, they're going to, they're going to die out there and you're not going to have a smell inside. What's that?
100%. Yes. Let's put it to rest, Luigi, right now.
Yeah. So that in itself doesn't occur. Now, at the same time, it doesn't mean that a rodent won't go, depending on the species, go into a building, consume a rodenticide, and then go outdoors, and then potentially poison a predator. Doesn't mean that can't happen. It certainly can, but it won't be happening, as far as I'm concerned, to a very great degree with the commensal rodents, the house mouse and the Norway rat, and you guys have the roof rat, of course. They have a much different ecology. They rely on human habitations and human structures and our food sources. Admittedly, in some parts of the southern United States and in California, because you have a warmer climate down there, those commensal rodents potentially spend more time in urban parks or in forests or wildland areas to a certain degree. Like there's a paper that came out in 24 on coyote secondary poisoning in California by Dr. Neve Quinn, Paul Stapp, and a few others from out there, that's shown potentially that, yes, commensal rodents are actually the vehicle of secondary poisoning in California. In Canada and in most of the United States, I would imagine, and certainly in Ontario, the only rodents that we were capturing in the forests, in the meadows, which are the high-risk landscapes where rodenticide was spilling over, they weren't commensal rodents. These were white-footed mice. And white-footed mice, there's no resistance to anticoagulants documented in their population. For which reason, if we are actually to control them or use rodenticides in an area that where they may end up consuming them, we can probably get away with the first generation anticoagulants. And those chemicals can be metabolized by the body much more quickly. We can kill those peridomestic white-footed mice or deer mice and pose a much, much lower risk to predators as a result. So if we're using these second gens, which are designed to combat resistance in the way which they were designed to be used, then we really shouldn't be causing secondary poisoning to a great degree. And also keep in mind that in our study, all the mice that I trapped, we had 111 that we tested. We tested their liver tissue. That's where toxins are stored. Just under 10% of them had chemical in their system. We did actually find one 100 meters away from a building that had diphenthylone in its system, which can only be used indoors, which does show that they will go inside, they will eat a rodenticide, and then potentially leave and expose a predator. But at the same time, these were white-footed mice. So if we were using a first gen in an area like that, if we were actually taking the time to identify the species, which, you know, in a lot of cases we come out and we see droppings and we say, oh, it's mice, I'm going to use this chemical. But just because the mouse is in a house doesn't mean that it's a house mouse. Species, you know, they have their own ecology. Just because you find them in the same areas doesn't mean they're all one species. If we're more frugal and careful with our chemical choices, I don't think we're going to be causing problems on the scale that would really pose a conservation concern. And even further to that, I don't really think that at this point we have the evidence to say that the industry is causing such a massive issue that, oh, we need to get rid of the anticoagulants altogether. No, I think that this is the tip of the iceberg in that, in a good way, in that we have the evidence to suggest a new usage protocol. We can use these chemicals for the right species in the right areas at the right times, lower our risks significantly. And further to that, you brought up the agricultural aspect. We haven't even investigated that. They've done it in Europe. They've done it to some degree in British Columbia. Usually when they do, they use the same methods as I use in an agricultural capacity, let's say in Spain or Germany or Ireland. They're finding that of all the rodents they trap, 20%, 40%, maybe 90% of those rodents in, you know, the agricultural field that borders on the big woodland where all the coyotes and the owls are, those rodents are exposed at a much greater degree in most cases, which is presumably posing a much greater risk to those predators. We haven't investigated the agricultural usage effects here in Ontario, let alone much of Canada, even the United States. That really needs to get done, and we may find totally different results with that. That's another thing that we do want to look into with my PhD work.
That's so
Yeah.
cool. Actually, our next guest that's coming on, we'll be talking about risk assessments. So it just made me think, as we're going out to maybe these commercial locations, whatever, places that are closer to wildlife areas, a lot of times manufacturing, they'll, be right next to those old agricultural fields or places that are now starting to grow up and now they've cleared land for areas of manufacturing. But taking the time to assess if there are peridomestic species and then think about, what types of rodenticide, if needed, do we need to put out? Because I think so often, especially on the commercial side, and Mike, you can attest to this, is I know we'll put out bait stations and the bait will sit there. It's part of their program, right? And you'll check it on a quarterly, whatever, monthly basis. But of course, some of us have started to think, well, can we put a non-toxic bait in there? Can we put something else in there or nothing in there and see if we have remote monitoring, is anything triggering? And once we have that data, then maybe we introduce a rodenticide of whatever sort.
I think it's a great point. I think it ties into what Luigi was talking about, is that we just have to be smarter about when we use it. It's not that it's a zero use protocol. It's just not and I think we've done this with pesticides across history too. We need to stop just blanket use of them for no reason. We need to make an application of them when we have the correct target pest in place and we're looking at controlling, that specific, what I mean? But to your point, too often we've moved away. When I first started in this industry, they would use the term baseboard jockey, right? That was the guy that walked in with a B&G, and regardless of what
Right,
problems
right.
was, he just hosed everything down, right? And we've moved away from that as an industry, and I think that it's time we start to do that with rodenticide usage as well, is that we're not just making these blanket applications when we don't necessarily have a call for them.
Yeah.
Exactly right.
To that point too, I do think that we've been slow as an industry to adopt it because the birth control products, the remote monitoring is still a big upfront expense.
Mhm.
And expense has always been the reason given for not utilizing them. But I mean, to our point here, if it keeps being used, if there's a high need for it, prices eventually go down.
That's right. The one thing that I'll mention when it comes to the expense aspect of things, back when I was, a 17, 18, 19-year-old idealist and I didn't have any real world experience, I just figured, well, it's about, people who are greedy who just want to make money. Well, if the manufacturer or the government is taxing to a degree that makes something so expensive that the companies won't buy it, the reason they're not buying it is because in order to make a profit, they're going to have to charge so much that people aren't going to pay for it. And a lot of people just don't understand that. And I've seen a lot of people. I've come in behind a lot of companies on jobs. I've seen a lot of people get ripped off, and I've seen a lot of people undercharge as well. I've done that, and the bottom line speaks the loudest. But at the same time, a lot of people have opinions related to rodenticides that really take into account nothing but the bottom line, which poses an issue in that, okay, you're thinking about the profit that you're going to make tomorrow as a result of applying rodenticides with impunity and using them however you want, not changing your usage protocol at all because you want to be stubborn. You think you're going to have those chemicals in another 10 or 15 years if things keep going? Like a lot of people in our industry just want to hit the opposition head on. I want it to be sort of the bridge from one side to the other and say, look, the industry has its point, but I'm still I call myself an environmentalist. I am, and I'm a conservationist, but I don't want to see these chemicals disappear. I think if they did, you would understand almost overnight just how essential they are as a result of the consequences. I just want to see better usage, responsible usage, and an all around sort of campaign for pesticide education and awareness, not just in the industry, but in the way that we present our industry to the customer, because people are becoming more and more aware of the problems that pesticides can solve, and rightly so. But it's not, it's a double-edged sword, and it goes both ways. It's not so simple.
We definitely more need more graduate students though to bridge these gaps, doing research with in the urban pest management realm, but rodents I think in particular. I haven't heard of many grad students doing what you're doing, so thank you for being a voice and I hope that you continue to spread the good word and do more research and find out all these things. Thank you so much.
Absolutely, yeah. Well, I know we're probably wrapping it up. I'll give you the scoop on how exactly I did this for anybody who might be watching that might be interested. Um, I'll be 27 in 2, 3 weeks. So I started this when I was I 24, 2-year master's degree. Once I finished my undergrad and I'd done, 3.5 years in the industry as a tech, okay, I want to do research and I want to do research on pest management. There's not really any professors, supervisors, principal investigators in Canada that look at the ecology of structural pests. You guys are lucky. You've got universities like UC, um, the Agricultural and Natural Resource Extension. You've got Bowling Green. You've got Purdue, obviously, even Cornell and a lot of other big ones. I needed to find somebody who was interested in rodents, and even small rodents are not so fashionable in the academic world in terms of a research subject anymore. I managed to find somebody and I said, hey, I did this study in my backyard. I was using Detex blocks. I had to explain what those were. And I found that, that there's no real difference between the different styles of exterior stations. But when you rotate them, the rodents will keep coming to the same station because it's covered in trees and blah, 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 all this stuff. Still trying to get that published. Hopefully I will. And he says, wow, okay, this is interesting. What do you want to do? Wow, there's this rodenticide resistance problem. And I explained it all. And Albrecht, my supervisor, he's an ecologist, a small rodent ecologist. He goes, This is great. Yeah, let's do it. This sounds awesome. And it worked out perfectly. And we run into conflict because he's an academic and I'm more of an applicator. But the marriage is perfect because he knows how to describe to me how to present this research to the academic community, which could get us more funding and get us out into the open, into the mainstream of the academic world, and illuminate this issue to everybody. I know how to present it to the industry because I was a technician. And so if you want to go about this type of work, I would say have a plan and have something very specific and applied that the industry would find interesting, and then find somebody who knows just enough about your topic sort of to take you on as a supervisor at a university. Won't be easy. Took me like 2 years, but it can be done.
That's awesome.
See? Perseverance, right?
There you go. Yeah.
And so many of us do want to see, there's no reason to kill everything. It's just like a hunter wants to, have conservation land to be able to hunt and keep these beautiful areas. I think it's the same with pest control technicians. We know that if we killed everything, well, that would be a sad existence. And so we want, the industry is getting better and better. But there's certainly a long ways to go. And we want to hear from those animal advocates and all these things. And when legislation is put forth that, suddenly no sticky traps or, it's like, well, wait a minute, we could have used those, for
Yeah.
all these other things. And so, just kind of the slash and burn effect isn't so great when, as your study suggested, these tools are here, we can be better at using them.
Hit the nail on the head. Exactly. Yeah.
All right.
Awesome.
Man,
Thank you
thanks so
so much.
much for hanging out
Yeah.
with us today. I appreciate it, man.
Awesome. Yeah, it was great to be here. Really thankful for being on. Really exciting. Lots of fun talking to you guys. Hopefully, I'll be able to get down to the States sometime in the near future. Well, actually, I'm going to be in March at the Vertebrate Pest Conference out in California. Um,
Nice.
but I've always loved our American friends to the south. That's where my last name comes from. My grandfather came up to Canada and during the Depression for work, and his family's been American going back to the Revolution. And Richardson is an old American North Carolina, Virginia name. So I've always had
Nice.
a great affinity for the Americans to the south.
Well, if you ever drive across the bridge and end up in Ohio or Tennessee, let us know.
Please do.
Absolutely, I will.
Perfect. Thanks.
Any last words, Luigi?
Well, be careful with your chemicals. They're necessary. Protect yourself and protect the environment, and the industry will be in good hands for many years to come.
Well said.
Like it.
Thank
Awesome.
you.
Thanks,
All
man.
right. Thanks a lot,
Appreciate
guys.
you. Have a great day.
Yeah.